In a world moving away from carbon-based fossil fuels, public transport has been an area of focus. For the railways, the move to electric trains is one way to reduce its carbon footprint, depending on how the electricity is generated, of course. Within the railways, there are two main ways utilised around the world to get the electrical supply to the trains themselves. These are overhead line and third rail systems. Each has its own advantages and disadvantages that have determined why one is more favoured over the other. We're going to explore them in this video. But is electrical power always the right thing? Stay tuned and I'll discuss that at the end. Surprisingly, both overhead line and third rail systems came into being at roughly a similar time, with overhead line being first showcased in 1879 at the Berlin Industrial Exhibition, and third rail system coming along shortly afterwards in the 1890s. It is fair to say that overhead line is utilised more widely across the world than the third rail system. So, in the spirit of the underdog, let's take a look at the third rail system first. The third rail system uses an additional rail next to the running rail that carries the electrical current. A shoe on the train then runs along the surface of this rail to transfer the electricity to the train. There is a variation of the principle of third rail design where a fourth rail is present to return the current. This is used most notably on the London Underground. While a different system, the pros and cons are largely the same. So let's start with the advantages of the third rail system. Firstly, it is cheaper to install than overhead line systems. It requires less new pieces of infrastructure like masts, etc., and is also easier to fit to existing track where there are a large number of structures. In some areas, its appeal may be that it's less visually imposing than having a large number of OLE masts appear out of nowhere. Its maintenance costs are also lower, owing largely to the fact that it's on the ground, so it requires less specialist equipment to access, while also not having the issue of people working at height. Lastly on the list of advantages is its weather resilience. While it is vulnerable to some weather conditions, it is not affected by high winds or the heat. It can be argued that it is more robust when issues such as falling trees do occur. Simply put, with the third rail being a solid rail and located on the ground, it's harder to break than a collection of wires suspended in the air. So now let's look at the other side of the coin, the disadvantages. Let's be honest, nobody can really argue with the fact that a high voltage rail being exposed on the ground is safe. It is dangerous for track maintenance, but also for members of the public if they find themselves on the track for any reason, such as having to leave a train. Also, let's not forget the animals that sometimes cross the railway as well. The system is also limited in a number of ways, because of the mechanical interface between the shoe and the conductor rail, as well as the gaps that have to be left in the conductor rails. The top speed of a train is limited. This makes it unsuitable for high-speed rail, and gives a ceiling for the upgrades to the line speed in the future. With third rail using DC, it is also not as efficient to transmit across long distances. This leads to more substations and other trackside equipment, while potentially limiting its use in more remote areas. Trains using third rail systems also require a transformer to be fitted, which takes up space and adds weight to the train. Third rail is also accepted as being less efficient for longer and heavier trains to use. Given freight trains tend to be long and heavy, this is a bit of an issue. Let's go back to weather again. I warn you, there will be a bit of a weather theme developing. Again, with a system being on the ground, flooding is an issue. Most people are well aware that electricity and water don't mix, so you can imagine having an electrified rail sitting underwater is not sensible at all. When it comes to the cold, ice build-up can be an issue as it gets between the shoe and the conductor rail, stopping the transmission of the current. During cold weather periods, ghost or empty trains may have to be run through the night, when trains aren't normally running, just to prevent the ice build-up on the conductor rail. I think it's fair to say that third rail does have some advantages, but also some very significant disadvantages, particularly when it comes to the safety of people. On to overhead line. Overhead line systems utilise line-side structures to suspend electrified wires above the track. The trains are then fitted with a piece of equipment known as a pantograph that runs along the wire and draws power from it. On the advantages, the first one is pretty obvious and significant. By having the electrified element suspended above the track, this then puts it out of reach of people and reduces the risk substantially. A byproduct of this is also a reduction of the cables snaking their way across the track, a very real tripping hazard. With overhead line systems generally being of a higher voltage and some carrying AC current, this makes them more efficient for power transmission over long distances. Another plus for the high voltage power supply is the need for onboard transformers is reduced or removed entirely. This is a piece of kit that can be removed from the train, creating space for more passengers and making the train lighter, so a double efficiency. Overhead line systems are also widely used for freight trains, in stark contrast to third rail. This is down to the high power delivery, as well as the overhead line being more suitable for remote areas, but also for other areas such as freight yards with lots of people working in them. Having an electrical hazard up in the air is far more palatable than having something close to your workforce on the ground. Finally, there is speed. Trains are able to run faster on overhead line systems, right up to the highest speed trains. This means that although upgrades would be needed, by installing overhead line equipment, infrastructure owners are leaving headroom to increase their train speed over time. That's the good. Now, let's look at the not so good. To suspend the wires in the air, structures are needed. They aren't going to hold themselves up at the end of the day. These structures need to be installed at regular intervals, which is a big undertaking when first electrifying a section of line or track. The high investment cost is one of the reasons that within the UK, progress of electrification has not been quicker. Then there is also the structures to be navigated. Low bridges, tunnels and viaducts all cause issues with the installation of overhead wires. Track under low bridges might have to be lowered to allow wires to be correctly positioned. Placement of structures on viaducts can lead to complex mounting arrangements that are hard to install and then maintain. A factor to also consider is that once the wires are installed, they have to maintain a certain relationship to the track. This is managed through what is known in the UK as heights and staggers. This ensures that the pantograph doesn't lose contact with the wires, but it can also limit modifications to the track itself without adjusting the overhead line. Then there is what happens when it goes wrong. If the wire does come off the pantograph, there is a high chance that it will get caught up in the pantograph. This can lead to a train pulling the overhead line down, and if that train is travelling at speed, it can travel for a long way, pulling the overhead line with it all the time. So when it goes wrong, it can be rather extensive and expensive. This ties in with the last disadvantage we're going to look at and takes us back to the weather. High winds, hot weather and ice, all weather-related enemies of overhead line. High winds can bring down trees, which in turn can fall onto the overheads, bringing it down. Items can be blown onto the railway and become tangled in the overhead line. A plastic bag can be enough to require trains to be stopped until it's removed. Hot weather can cause the wires to expand and sag. This loss of tension can dramatically increase the risk of the wires getting tangled in the pantograph. This can lead to speed restrictions or the stopping of the train service in extreme cases. Lastly, ice. Similar to the third rail, ice build-up is an issue during the winter months. The wires are perfect for icicles to form on if the conditions are right, while pantographs are not designed to knock them off. So that's the comparison between the overhead line and the third rail. While overhead line does allow for a more efficient electrical transmission and higher train speeds, it costs more to install initially and is also much more vulnerable to damage. With third rail, it has some advantages, but it's pretty easy to see it isn't the safest style of equipment. With a move to decarbonisation, electrification of the railways is on the increase, but is it all positive? Before we look at that, I wanted to take a minute to say that if you're enjoying this video and want to know more, do check out my collection of ebooks available at the link below. You can get my free Guides Can ebook by simply popping your email in the form at the link below as well. Right, back to it. There are some things to consider about the move to electrification. Firstly, power supply. By moving to electric trains, there is now a reliance on a country's power grid to be able to supply enough power consistently to meet the demand. Diesel trains are free, to some extent, from this constraint. Indeed, it is likely that trains used for track maintenance or renewal will continue to be diesel-powered, so that they can function when the power is turned off during works. They are also able to function for longer than current battery-powered trains. There is also the fact that the diesel train can run on the track with overhead line, third rail, or no electrification at all, which gives them a great level of flexibility. As we've touched on when looking at the disadvantages of overhead line, electrification costs a substantial amount of money initially, and in not all areas will it be cost-effective to do the upgrade. Any benefits of diesel you think I've missed? Drop them in the comments. The move to electric will continue, but will we see 100% electrified railway and trains? I hope you found this video useful. Please hit that like button and don't forget to subscribe. Thank you.